Biostats Exam 3. I'm going to start from the beginning.
Should I take this first?
We'll do it after. That way you can sit in. Unless you have to go.
It will depend on how long this takes, but...
Okay, stop me
I'll
so
stop
that you
you.
have at least 10 minutes
Okay.
to take it. Okay. So, use the following to answer questions 1 to 2. 5 people volunteered to be part of an experiment that looked at the effects of alcohol consumption on motor activity, where they practiced free throws before and after consuming alcohol. They had 3 minutes. Is there an effect of alcohol consumption on free throws? So, let's look at our data. So we have 5 people, right? And we have 2 measurements for each person. We have before alcohol consumption, after alcohol consumption. And our dependent variable is number of free throws. So before we even move forward in answering the question, where do you think this question is going? What do you think they might ask you?
Do a hypothesis test?
Okay, and what kind of test? Statistical test do you think we'll be doing?
One sample T matched.
Not one sample,
Matched.
it's a matched pair.
Matched pair.
So the hypotheses being tested are that the null is the mean equals to 0, or the alternative, the mean is greater to 0, or the mean represents the mean of the differences in free throws before and after. Assume the differences are normally distributed. So now we got a new set of information, how they want us to treat the data, right? So at first we decided that it was going to be a matched pair test, but in this case we're looking for a difference of 0, and they want us to look at the difference scores. So now we're going to do not a matched pair, but what other kind of test? Go one sample, right? Because
One
now we're
sample
going to create a new variable,
Okay.
the difference score, right?
Yeah.
And I think here, they are calculated for us, where the mean difference is 1.8, and the standard deviation of the difference is 3.015. Does that make sense? Okay. So what is the value of the test statistic? How do we get that?
You would do...
So we're looking for t.
Mm-hmm.
What is the formula for t in this case?
X bar minus mu
X bar minus mu
Over
over S to the square root.
S whole square
s square root n,
root.
where x bar is equal to
1.8.
1.8. Our mu is, our hypothesized mu is
0.
0. Our given standard deviation is
3.5.
and our n is
5.
5. So if we do the math out, what do we get for t?
Negative 1.3.
1.3.
Or 1.3, sorry. Yeah.
1.34.
Yeah, 1.34 is close. So we're gonna need to look up t, right, to get the p-value. So question 2, what can you say about the value of the p-value? So how many degrees of freedom do we have?
4.
4. So df is n minus 1. In this case, n is 5 minus 1. Our degrees of freedom is 4. So we're going to look up our p-value.
It's between 0.15 and 0.1.
Yeah, so our p is somewhere between,
Point, yeah, 1 and 0.15.
so it's, is that right?
Yeah.
So should we reject the null hypothesis at the alpha equals 0.05 level? If we know that our p is somewhere between 0.1 and 0.15.
No.
No. Does that make sense? P is less than 0.05. We do not reject the null hypothesis.
So if that p-value is less than 0.05, we would have rejected it.
Yeah.
Yes.
Okay. Yeah. So we're not.
And just think about that rule that when t is approximately 2, that's when alpha approaches 0.05.
If it's any bigger than 2, you usually always reject it. Maybe it's like
Most
3
likely.
or 4 or something
Yeah.
like that. Okay.
Excuse me. So for x bar equals 1.8, we're just assuming that the mean difference.
Excuse me.
That is the mean difference, so it's just calculated for you. So if you went ahead and subtracted 12 from 15, you would get 3, and then 16 from 13,
Okay.
you'd get 3, and so on and so forth. If you take the mean of the differences, it's 1.8. That's where that number came from.
And the s squared is just there for extra. I don't need it.
Okay. So questions 4 through 6. Some researchers have conjectured that the citrus scent prevents deer from eating tomatoes from gardens better than a deer off. In a garden containing 30 plants, 15 are randomly selected throughout the garden and assigned to receive citrus zest. The remaining plants receive deer off. At the end of the study period, the number of tomatoes eaten by the deer is tabulated. The following results are obtained. So deer off, our mean is 10.5 tomatoes with a standard deviation of 2.5 tomatoes. And our citrus group, the mean is 15 tomatoes with a standard deviation of 3 tomatoes. So first, what kind of statistical test are we going to do to compare these groups? Two sample independent samples t-test, right? They're not matched. They're not from the same plant. They're not twins. They're not before and after. So we have a independent samples t-test. Does that make sense? Okay. So question 4. What is a 90% confidence interval? So we're going to use the conservative value for degrees of freedom for mu2 minus mu1. So how do we get a confidence interval?
I'll make the margin bigger.
What's our formula for confidence interval?
X bar 2
X bar 2
minus X bar 1
minus X bar 1
plus or minus
T
star
Okay.
and the square root
Times the square root of
n1 squared over s1
Or
s
squared. S squared. Okay. Plus 2 squared.
Okay, so is there anything we have to look up?
T
T
star.
star.
Okay, let's look it up. And we're looking for a 90% confidence interval.
So
So
for-
it's a little bit different.
So to get T star, we would need to know degrees of freedom, and it's whatever one is smaller, right?
Mm-hmm.
So in this case,
They're
be
both
equal.
15.
Okay. So
So
we have 14.
14.
Mm-hmm. everyone else by right? 1.76. Okay. So now we have everything, right, that we need to get our confidence interval. X2 is 15 minus X1, which is 10.5, plus or minus our t-statistic, which we decided was 1.76, times the square root of the standard deviation of S1 squared, which would be 3 squared over our n, which is 15, plus 2.5 squared over 15, and if we solve for this, we get 4.5 plus or minus about 1.78. Yep. So our confidence interval is
2.72 to 6.28.
right.
Why is, for this, like, the DERA, why is the S not S1 and it's S2?
Good question. I think it's just a typo.
Does that screw anything up, really?
What do you mean?
Like, with our calculations?
It would screw things up only if our ends were different.
Okay.
But it's just a typo. The S2 should belong with the X2.
Okay.
Yeah. But in this case, because our ends are the same, it doesn't matter. But yeah, it's just a typo. S2 should belong with citrus.
When can I just ask you a question?
Sure.
So this is like a 2 sample
Right.
independent test. Could you like give an example of, is there a way this could be matched pairs?
No.
Okay, could you like give
How
an
can
example
it
of one that is a matched
be
pairs?
matched
Can you confuse
pairs?
between the two?
If
I didn't
they
need the
took
specific
30
example.
plants,
Mhm.
potentially, if they took 30 plants and used deer off this year,
And then
and
the
then
citrus
next year
stuff.
use the citrus next year.
Okay. So they would all have to get the same treatment one time and then like a different treatment
Yes.
another time?
There's other confounders you'd have to worry
Yeah.
about, but
Okay.
very simply
Can
that
we
would
just-
be a matched pair.
Okay.
That our first example would be a matched pair because it's the same person before
Before
alcohol and
and
after
after.
alcohol.
Okay.
And the reason why we actually did a 1 sample t-test is because we took a difference, because we were
And then that
looking
was your new
for
variable.
a hypothesis that our tested our difference score is 0.
Okay.
In that case, you can turn a matched sample into a one sample.
Okay.
You can have other hypotheses too, that your difference is